righty, how's everybody doing today?
I think my teacher finally got it together for physics. So.
Oh, how's that? What happened?
He posted stuff Sunday instead of Thursday. That's due next Sunday. So.
Wow. So how is he posting? Is he posting on Blackboard or what?
Yeah.
Let me ask y'all a question. Have y'all noticed teachers using Blackboard or not using Blackboard? I know I don't use Blackboard because to me it's kind of prehistoric. But what about you other teachers? Do they use it or not use it?
He's my only other teacher, and he uses it. So I don't know about anyone else.
Okay, the rest of the class not going to talk to me, so. Okay, looks like we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of 28. So we got half the class. Okay.
Let me just, before class starts, let me read you one of my test problems from yesterday.
Okay.
You should be able to figure it out in your head if you can make sense of it. A man steps out of his tent and sees a bear. He runs 1 mile south, turns and runs another 1 mile east, and then turns and runs an additional 1 mile north, arriving at his camp. What color was the bear? What was his displacement? And what color was the bear? That is a test question. I'm not lying.
I don't even understand how you can ask that.
I think the bear thing was a joke, but the displacement is extremely confusing to me. You would think it would be 1 mile because 1 mile south.
Well, yeah, you're 1 mile from camp.
But
yeah,
it says
the displacement would be 1 mile.
But listen to this. It says a man steps out of his tent and sees a bear. Is his tent not at camp? Because it says he returns to camp. After his running around, he arrives at camp.
Well, it sounds like to me you did a triangle instead of a rectangle. I mean a square. He only went 3 directions.
Yeah, but he didn't do a triangle. He went south, east, and north. It doesn't complete the triangle.
Exactly. He's 1 mile from the camp.
Yeah, that's why I messaged.
He's 1 mile. Technically, he's 1 mile west or east of the camp.
Yeah.
I don't know.
I would call funny business on that.
I wrote him a nice little paragraph. I was like, I'm not sure what you're trying to ask here, but the color of the bear is the least of my worries.
If you're at the North Pole, the bear is white, and if you go south 1 mile and then over and back up, you'd be back at the same place.
Maybe you're right. Maybe he's trying to be funny.
It didn't work out well for him.
All right. Remind me, I gave y'all a question. Didn't I give y'all x plus 1 times x squared minus 3? Or what did I give y'all yesterday? To finish class, I gave y'all a question to work on. Which one was it? Or was it the square root of x minus 4? That's it. Yeah, that's what it was. I appreciate y'all's input. Thank you. So here we go. H of x is equal to the square root of x minus 4 cubed times the square root of x plus 4 to the 5th power. Now, I think I told y'all that there's no way you're going to do this by algebra unless you take a whole page and expand both of those out. What are we talking about now? Unless he's at the North Pole, it's cause every one of us sucks doing him. It's here to take the trash away. Oh, you're talking about the trash, the garbage truck outside my window. Okay. So I'm gonna change this, and I'm gonna say x to the 1/2 minus 4 to the 3rd, x to the 1/2 plus 4 to the 5th. Now, if you haven't started it, I want you to use the chain rule, and you're going to do the chain rule and the product rule. Now, this is a very good test question because it's got 2 in it. It's got 2. First times the derivative of the second plus the second times the derivative of the first. All right, go to it. Now, I don't know. Just show me a thing of hands. How many of y'all have done this problem and don't have any problem with it? Show me some hands if you've done the problem and you don't have a problem with it. Okay, it looks like to me that none of y'all did it. Okay. I don't see any hands. Y'all suck. I guess y'all are worried about the bear. Okay, nobody's going to talk. Are y'all mad at me or something? Did I do something? Did I offend you? Okay.
I think it's more along the lines of we all hate unmuting our mics and then remuting them.
Okay, well, just show me your hands then. Well,
I'll be honest, I was truly worried about that bear. So, yeah.
So that bear affected you.
Well, the whole test and the bear, yeah.
Okay. Well, I'm sorry about the bear, that you were traumatized by the bear. All right, and here we go.
We'll just have to grin and bear through it.
Okay. Ha 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 ha. It was teacher before online classes. Be quiet, everyone. Teachers during online class. No one will talk to me. Okay. All right, here we go. First times the derivative of the second. I'm going to write it in green. No coughing in class. I lay off in Marlboro Reds and thing will kill you. Plus the second times the derivative of the what? First. So the first times the derivative of the second. So I'm going to use the chain rule. I'm going to use the peach. Where's my peach? Can't find my peach. I'll just use the pink. I lost my peach. All right, so that's going to be 5 times x to the 1/2 plus 4 to the 4th. And then what's the derivative of what's inside? 1/2 x to the negative 1/2 plus the second times the derivative of the first. 3 times x to the 1/2 minus 4 to the second times 1/2 x to the negative 1/2. Now, it might behoove you to that's about all you can do. It might behoove you to change that to 1/2 square root of x. and that 1 over 2 square root x to help simplification. So I'm going to rewrite it. X to the 1/2 minus 4 quantity squared. And then I'm going to do 5 times x to the 1/2 plus 4 to the 4th power 1 over 2 square root of x plus x to the 1/2 plus 4 to the 5th power 3 x to the 1/2 minus 4 to the 2nd 1 over 2 square root of x. Now you can combine that 3 and that 5 with that and make it a little bit easier. And that's going to give me 5 over 2 square root of x times x to the 1/2 minus 4 to the 3rd power x to the 1/2 plus 4 to the 4th power plus 3 over 2 square root of x x to the 1/2 plus 4 to the 5th power through x to the 1/2 minus 4 to the 2nd power. And I'm going to leave that as the answer. Because as you can see, you could factor out a, no, because that's, well, you could factor out a x to the 1/2 minus 4 to the 3rd power times x to the 1/2 plus 4 to the 4th power. You could factor that out, but that's pretty much it. Did anybody try it? Did anybody get that? Okay. Y'all are just going to be, okay, that's fine. Let me find one. Here's one. I'm just going through and picking out problems that I would put on a test. So, how about G of W is equal to W to the 3rd power over W plus 3 to the 5th power. Okay, what rule?
Quotient.
Quotient rule, and you're also going to use the chain rule with the quotient rule because of that W plus 3 to the 5th power. So, excuse me. So that's going to be denominator times numerator prime minus the numerator times denominator prime, over denominator squared. All right, take a minute and do that one. It's 3:27. I'll give you 1 minute. Let me just time you. That way it'd be better. Give you 1 minute to work that out. Then we're going to do another nested problem. All right, that's a minute. So, denominator, w plus 3 to the 5th power, times numerator prime, w to the 3rd prime, minus, bring out our old red marker, numerator times denominator prime. Over denominator squared. Well, what's w plus 3 to the 5th power squared? 10th.
To the 10th.
So it's not like that's very difficult. Remember, the denominator is not exactly what we're not really worried about that.
By the time we hit our unmute button, you've already answered the question.
I did what?
Thank you.
What did I do?
By the time it takes us to hit unmute on our mics, you've already answered the question. Like we're attempting to answer, but
I'm sorry. Well, just leave them unmuted unless you got a dang dog in the back. Just
I
leave
have
them unmuted.
really don't want mine unmuted.
Okay.
You really don't want to hear Hart's dog today, or mine.
I don't want to hear no dog, period. All right, so here we go. W plus 3 to the 5th power. And take my pink, and that's going to be 3W to the 2nd power. Minus brackets W to the 3rd power times 5W plus 3 to the 4th power, and I'll do the derivative of what's inside for y'all. 1. I try to contribute. There you go. Now all you got to do is what? Simplify it, which you really only going to do is just bring the 3W out front and the 5W to the 3rd out front. That's pretty much it, and put a minus sign in front of it. But let's go ahead and write it. 3W squared times W plus 3 to the 5th minus 5W to the 3rd times W plus 3 to the 4th over W plus 3 to the 10th. Now, you could cancel out, because this is a common denominator, you could cancel out, but you'd have to put it on a separate one. So that would be 3W squared over W plus 3 to the 5th minus 5W to the 3rd over W plus 3 to the 6th. You could do that, but I'm just going to leave it like this. Question on that one? All right, let's try nerding. I hope y'all are learning something here, because that's the way that I've always, with the basic laws, this is the way that, you learn them. You got to do them over and over. There's some of y'all that don't believe that. I don't know why, but there's some people that miss test, but I don't see how you miss test either. But anyway, equals S plus 1 to the 5th power times the square root of S minus 1. All right, turn on the stopwatch. I'll give you a minute to get started on it. Product rule. First times derivative of the second plus the second times derivative of the first. Well, I want to put denominator in everything. Just throw in, where do you get some of this stuff?
I'm gonna be honest, I'm not aggressively social. So it's literally me sitting here with my own thoughts. So you can imagine how the crazy just sits there and festers.
Okay, okay. Okay, that's 1 minute. Amazing how a minute goes by quick. H prime of S is equal to first times the derivative of the second. Wait a minute. Times the derivative of the second, S minus 1 to the 1/2 power prime, plus the second, S minus 1 to the 1/2 power times the derivative of the first, S plus 1 to the 5th power. And that's going to give us S plus 1 to the 5th power, 1/2 S minus 1 to the negative 1/2 times 1, plus S minus 1 to the 1/2 power, 5 S plus 1 to the 4th power times 1. And looks like to me, I'm going to pull out the 1/2 and the 1, and I'm going to send the S minus 1 downstairs. So S plus 1 to the 5th, that 1/2. Well, I'm going to leave it all as 1. 1/2 S plus 1 and S minus 1 to the negative 1/2. You could put that negative 1/2 downstairs if you wanted to.
Yeah.
Plus 5 S minus 1 to the 1/2 times S plus 1 to the 4th. We good?
We good. Or
Let's do a nested problem. Those are always good to discourage you.
the chain rule is my favorite.
Say again?
The chain rule is my favorite for some reason.
Yeah, because it's simple. It is. Third root of the 5th root
You just got to remember not to forget parts.
of the square root of x. There you go.
Oh, that's fun.
The third root of the 5th root of the square root of x. Now, the key to this one is rewriting everything and using your exponential laws first. So if you suck at algebra, you're going to suck at this. You don't need any more encouragement. So g of x is equal to x to the 1/2 raised to the what? 1/5 raised to the what?
1/3.
And what's 1/3 times 1/5?
1/15.
And what's 1/15 times 1/2?
1/30.
It's a miracle. But you'd be surprised how many students. And now you just take the derivative. Now this is a problem right here. Do you know how many people, if I gave 30 students this problem on a test, guess how many would skip it? At least 10. Why do they skip it?
Too many steps.
Because
Fractions, roots. Ugh,
it looks what?
it looks hard.
It looks difficult. Yeah, right here. This looks like, oh my God. So you just don't do it. So that's going to be 1/30 x to the 1 over 30 minus 30 over 30, which is 1/30 x to the negative 29/30. And you can put that downstairs if you wanted to. I'm just going to leave it like that. Here's another one that I put on a test, and people will get it wrong. You ready? F of x is equal to pi squared.
Oh,
0.
0, yeah.
Exactly.
Pi is a number.
It's a number. Pi squared is nothing but a number. But students, for some reason, they just do everything they can to screw that up. Okay?
Oh, it's 2 pi.
Yeah. 2 pi to the first. I guarantee you somebody did that.
Imagine the world where pi is a variable.
Yep.
People do it with E too, just so you guys are aware.
Yep.
Do it with E.
Exactly. X plus 2 quantity squared times 3x minus 4x to the 5th to the 100th power over 8 minus x to the 7th.
See, there's like, why?
What?
Make me break out a whole new sheet of paper now.
I know. Well, you could just do what a lot of people do, just don't do it.
I paid a lot of money to do stuff.
Okay, you did. Oh, God. You one of those people that want to be self-improved. All right.
No, I'm one of those people who doesn't like wasting money.
Denominator times numerator prime minus the numerator times the denominator prime over denominator squared. Now, I'm going to do the denominator squared for y'all. I'll do that for you. That'll be 8 minus x to the 14th power. You're welcome. Take a minute and start it off. Okay. So denominator times numerator prime. Well, I'm going to put that in brackets because that's going to be the product rule. X plus 2 quantity squared times 3x minus 4x to the 5th to the 100th power prime minus the numerator x plus 2 quantity squared times 3x minus 4x to the 5th raised to the 100th times 8 minus x to the 7th prime. Eight minus x to the 14th power. Now, we got to do the product rule here. So let's go ahead and do that. So 8 minus x to the 7th power. First times the derivative of the second Well, that's going to be 100, 3x minus 4x to the 5th to the 99th times 3 minus 20x to the 4th. Y'all check me. Minus brackets x plus 2 quantity squared times 3x minus 4x to the 5th to the 100th power times 7 8 minus x to the 6th power times 1. I'm not going to worry about the denominators. Denominator squared, we already did that. And I'm looking, really there's nothing, that 7 can come out front, and that 100 can come out front, and that's about it. You're just going to be left with a bunch of polynomials. So you can do 100, 8 minus x to the 7th power, x plus 2 to the 2nd power, 3x minus 4x to the 5th to the 99th power, 3 minus 20x to the 4th power, and then minus 7 times all that trash. So that's going to be x plus 2 to the 2nd power, 3x minus 4x to the 5th to the 100th power, and then 8 minus x to the 6th power, all over 8 minus x to the 7th power, or 14th power.
I feel like there was a step missing somewhere.
Well, I don't think there is. I think I did everything.
The derivative of the second term. Or
Say again?
The derivative of the numerator.
First times the derivative of the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator.
Right. And then
There's the product rule right there. I just did the product rule right there. Oh, shoot. Did I? No,
okay.
I didn't. Shoot. Thank you, Mr. O'Quinn.
Sorry to be the bearer of bad news.
First times the derivative of the second plus the second, which is 3x minus 4x to the 5th, 3x minus 4x to the 5th to the 100th power times the derivative of the first, which is 2 times x plus 2 to the first times 1. And that you got to put that in there. This is really not, I wouldn't give you this one on the test because it's too much.
Yeah, I was like, how are you fitting this all on one page?
Yeah, that's not a good test question. I think that's a mess.
I
But
understand it, and it's doable. It's just lengthy as tar.
yeah, let's do another one. Well, before I do another one, I want to pull up some stuff. I don't know if I've given you these or not, but let's go ahead and let me pull them up for you. Let me go to the handy dandy, and I'll pull them up and derivatives of logs. My computer is running really slow this morning. Go ahead and copy those down as soon as it comes up. It should come up. Okay, copy those down. And I'll pull up the derivatives of the trig functions here in a second. if f of x is equal to the natural log of x, then f prime of x is equal to 1 over x, which is du over u, which is 1 over x. And if you're taking the natural log of a function, the function is in parentheses, so you do 1 over f of x, and then you take the derivative of what's inside. So if you have f of x is equal to the natural log of f of x, I'm going to put that, I'll show you this in just a minute. That's going to give me 1 over f of x times the derivative of what's inside. Because that right there is in parentheses. Well, I'm sure I'm writing these down because if you have f of x is equal to log base a of x, then f prime of x is equal to 1 over x natural log of a. That feeds off the change of base formula. And the same thing with a function, just you got to take the derivative of what's inside. So f of x is equal to log base a of a function, put that function in parentheses, and that's going to be 1 f prime of x is equal to 1 over f of x times natural log of a times the derivative of what's inside. So if you wanted to write those like I do, that's the way I write them. And it just froze up. There we go. So there's number 1. There's number 2. There's number 3. And there's number 4. Now you're going to see a lot of those on the test. This is where we get into the functions that what section, Mr. O'Quinn, did you say the functions were in?
The chain rule was in 3.7. 3.4 was trig function.
Derivative of trig functions. And these are pretty simple. I mean, all you got to do is memorize them. And there they are. Derivative of the sine is cosine. Derivative of cosine is a negative sine. Derivative of tangent is secant squared. Derivative of secant is secant tangent. Derivative of cosecant is a negative cosecant cotangent. And the derivative of the cotangent is cosecant squared. Negative.
Just that simple.
Cosecant. But
If it starts with a C, it's going to be negative.
Good job. Where did you
Appreciate
get that at? You are so smart.
I've taken part of this class already.
You're experienced. How about that?
She's a little smart,
Yeah, she's experienced.
just a little.
I personally love this one when they tell you to find X on a test. Where's my, that one's always good. And the directions say find X.
And you found it?
Here it is. That's always good when you know, there it is.
Not wrong.
Yep. When you think a question is that simple, chances are it's not. So, derivative of the sine is cosine. Derivative of the derivative of the cosine is the negative sine. Derivative of the tangent is secant tangent. I mean secant squared. Derivative of the secant is secant tan. Derivative of the cosecant, like she said, is the negative cosecant cotangent. And the cotangent is negative cosecant. Now, I don't care how you memorize them, but if you want to do well on this test, you're going to see at least 2 or 3 of those. Okay? And we're going to go into them more in the next class.
Oh, come on, just derive them by hand as you need them.
Yeah, we can do that too. Yeah, we could derive them if y'all want to. That's even better. And try another one. Derivative of exponentials. And there you go. Now, the only thing you got to remember technically is EX, and then remember the chain rule. If you have, and let me just, and I give you this, I showed you this the other day. If you have e to the negative 2x, f of x is equal to e to the negative 2x. Well, you got to put parentheses around that negative 2x because that's you got to do the chain rule. Now, if you have f of x is equal to e to the x, it works there. That's why I don't teach students to remember. I tell them to use the chain rule with both of them. So let's use the chain rule with this one. Okay? The derivative of e to the 2x is e to the 2x, negative 2x. But then you got to take the derivative of what? What's inside. So your final answer there is negative 2 e to the negative 2x. Do the same thing here. The derivative of e to the x is e to the x. And what is the derivative of x? 1. So your answer is 1 e to the x, which is e to the x. So if you just learn the chain rule with both of them, it makes life a whole lot easier. Okay? And that's that one right there. Now this one is e to the u. Well, if I get, that'd be e to the u times the derivative of what's inside. The derivative of u, that's what that means. So I just showed you that right here. Now, if I have the derivative of, I don't know, 2 to the x power, let me do that one. If I have f of x is equal to 2 to the x power, then that's going to be 2 to the x, f prime of x is equal to 2 to the x times the natural log of 2. Now you need to make a note on that one because sometimes that'll get you on a test. And of course, the only difference here is the chain rule. If I give you 2x right here, f of x is equal to 2 to the 2x. Then I do everything like I've been doing. F prime of x is equal to 2 to the 2x times the natural log of 2. What is the derivative of what's in the parentheses? 2. So that would be 2 to the 2x times 2, or times 2 natural log of 2. 2 to the 2x times 2 to the 1. You could make that 2 to the 1 plus 2x if you wanted to. Natural log of 2. Now this is where we're heading next class. You got 3 other functions. Now, I'm not spending a lot of time on them because one, trigonometry is nothing but what? Regurgitation. The only thing you got to remember is the chain rule. If I give you f of x is equal to the sine of negative 3x. Oops, let me make this bigger. F prime of x is equal to negative 3 times the cosine of 3x, negative 3x. And see, that's why you got to be careful when you're doing the chain rule. You got to know the chain rule. Okay? Now you could put that, you know, that negative 3. You could rewrite this with a negative out front, and that'd be 3. You could argue 3 cosine of 3x. You could. But we'll just leave it like this for right now. Now, I will tell you this. That's not going to be too challenging for you. Most of y'all will be able to regurgitate the derivative of sines of cosine, derivative of cosines, negative sine, and so on. Most of you will be able to do that. The problem is y'all will kind of bog down on these. That's where you're going to bog down. On the exponentials, e, and natural logs, or logs, whichever. So, you know, while I'm going to give you the same amount of questions on the test from each section. Now, I think you're telling me, Mr. O'Quinn, that 3.4, does it have the e and the natural log in it, or is it just all trig?
It's all trig.
Well, there's got to be somewhere where they show you the, have anybody looked at the homework yet and seen the natural log and the inverse of the exponents?
I've been doing notes, but I'm not going to lie to your face and tell you I have looked at it yet.
Okay.
I'm through 3.6 and it hasn't come up yet.
Okay, the outlines say 3.7 or 3.6?
I'm pulling it up now. Give me 1 sec.
It's got to be, unless they're holding it off for later. Somebody look at the outline and see if they're holding off for the logs and the inverses.
It all says in the comments that they're in the 3.4 homework.
Okay, 3.4.
It's got logs and exponentials as 3.9 on the outline.
Okay. Yes, Ms. Patel, if you need to go, go ahead. Okay.
Thank you.
So let's look at a couple of natural logs. And again, I'm just doing problems. I'm just doing them so I can, you know, hopefully y'all will send me some questions. And I still haven't forgot your questions that you sent, but those are not my priority right now. These are my priority. I'll get you those. I'll answer those before you turn in your homework. Where's my, there it is. All right, let's go with the natural log of x squared minus 1. Excuse me. Natural log of x squared minus 1. F of x is equal to the natural log of x squared minus 1. Now, as I said, the derivative is going to be 1 over whatever the function is, x squared minus 1. And then what do we got right here? What are those called? Parentheses times the derivative of what's inside. So what is the derivative of x squared minus 1?
2x.
2x. So now you've got to multiply that by 2x. And f prime of x is equal to 2x over x squared minus 1. All right, let's try nerd. T of y is equal to y times the natural log of 1 over y. First times the derivative of the second plus the second times the derivative of the first. First times the derivative of the second plus the second times the derivative of the first. So y, well, this is going to be, technically, I'm going to change this. That's going to be 1 over y, so that could be y to the negative 1. The derivative of 1 over y, that's going to come out to be, let's see, natural log of 1 over y, yeah.
One over y times 1.
Yeah. 1 times 1 over y times 1. So 1 times 1 over y times 1, which is 1 over y, plus the natural log of 1 over y times 1. And I got the natural log of 1. I'm trying to see where they got a negative. They got a negative because of the negative. They got a negative somewhere. I don't know where they got that negative. They've got the answer as the natural log of 1 over y, which is right here, minus 1. There's the 1, y over y, but there should be a negative here. Does anybody see a negative?
I got 1 plus natural log of 1 over y.
It's supposed to be a negative there. I'm going to have to look at that one because I can't find out where they're pulling that negative from.
Unless it was negative y times natural log of 1 over y.
I'll have to look at this one. They're go ahead and put the answer down as that one, but I'm going to have to redo that one because they're coming up with a negative 1, and I don't see where they're coming up with that. Has anybody got any input there? Okay.
Yeah, I mean, the first term goes to y over y plus natural log of 1 over y.
Yeah, there should be 1. Should be a positive 1. I don't know. I'll have to look up that one. I'll look that one up, see if I can find. But they don't. They got a negative. They got a negative 1. 1 over y. Let me figure that one out. I want to move on and get another. I want to get a exponent. F of t is equal to e to the 3t. F of t is equal e to the 3t. So this is just got your parentheses right here. And you know that the e to the 3t is e to the 3t. But what's the derivative of 3t? 3. So f prime of t is equal to 3 e to the 3t. And g of z is equal to 2/3 3z minus z squared Now here, you've got a number raised to a variable. So you're going to do the natural log of 2/3 times this actual thing right here, and then the derivative of what's inside. And the derivative here is going to be 3 minus 2z, isn't it? So we're going to have 2/3 times 3z minus z squared times the natural log of 2/3 times the derivative of what's inside. And the derivative of 3z minus z squared is 3 minus 2z. Do you see where people could bog down? You can actually bog down on some of these. So, question, gripe, complaint. Okay, now what I want everybody to do, I want everybody to work on all the homework and start sending in questions, and we should be able to finish this, hopefully by the end of the week, we should be able to finish with some of your homework questions. Anybody got questions? Nobody's got any questions. I went over this material so well that you don't have any questions.
I mean, I'm still trying to figure out where that negative came from.